Let's find the second derivative of f of x. So here we have f of x equals 2e power negative x cube. Let's find the derivative of f of x, that is f prime of x. This is basically the first derivative of f of x. And so this equals 2 times the derivative of e power negative x cube is e power negative x cube. And then using the chain rule, we find the derivative of negative x cube. And this equals we apply the power rule. This is negative 3x squared. And so we multiply this with negative 3x squared, which is the derivative of negative x cube. So let's simplify this. We have f prime of x. This equals, we have 2 and negative 3. When we multiply these two, we get negative 6. And then x squared e power negative x cube. So this is the first derivative of f of x. We should find its derivative one more time so that we get the second derivative of f of x. So we find the derivative of f prime of x, which we write as f double prime of x. And this equals, and this time we have to use the product rule of derivatives to find the derivative of this expression. So let's consider the first expression as negative 6x squared, and then the second term as e raised to the power of negative x cube. First, I put the first term as it is, that is negative 6x squared, and then multiply this with the derivative of e power negative x cube, which is e raised to the power of negative x cube. And once again, when we apply the chain rule to find the derivative of negative x cube, we get negative 3x squared, and then we put plus, and according to the product rule, we know put the second term as it is, that is e raised to the power of negative x cube, and then multiply this with the derivative of the first, which is derivative of negative 6x squared, and so this equals negative 12x. Let's simplify this. So here we have the second derivative of f of x. This equals we have negative 6x squared times the product of this one is negative 3x squared e power negative x cube, and then we have negative 12x. So I put negative 12x first, multiplied with e raised to the power of negative x cube. And so this one is, when we multiply these two, we basically get negative 6 times negative 3 is positive 18, and x squared times x squared is x power 4 e power negative x cube minus 12x e power negative x cube. We can factor the e power negative x cube since we have it in the two terms. So let's factor this e power negative x cube, and then I write this as 18x power 4 minus 12x. So this is the second derivative of f of x. We now determine the second derivative of f evaluated at 0. So let's plug in x equal to 0 into the second derivative of f of x. So therefore this becomes f double prime of 0, and this equals, we should replace all x by 0. So therefore this becomes e raised to the power of 0 cube times 18 times of 0 power 4 minus 12 times of 0, and this one is basically 0. E power 0 is 1 times of this one is 0 and this is 0. So 0 minus 0, we get 1 times 0 equals 0. So therefore we see that the second derivative of f at 0 equals 0. Now let's determine the second derivative of f evaluated at 2. So we have to plug in x equal to 2 into the second derivative expression. So therefore we get a second derivative of f at x equal to 2. This equals e raised to the power of, replace x by 2. This is negative 2 cube times 18 times of 2 power 4 minus 12 times of 2. And so this equals negative 2 cube is negative 8. So this is e power negative 8 times 18 times of 2 power 4 is 16 minus 12 times 2 is 24. Let's simplify this. This equals, I can write this as 1 over e power 8 times 18 times 16 is 288 minus 24. And this gets simplified to 288 minus 24 is 264 divided by e power 8. So this one is f double prime of 2. We can also give its decimal approximation, and this is approximately equal to 0.0886 approximated to 4 decimal places. And so this is the value of second derivative of f at x equal to 2.